Hi, Assalamualaikum everyone. My name is Noraidatu Asaleha binti Ghazali and my ID student is 2024250792, and right now I would like to introduce you about wind turbines. So, what is wind turbines? Wind turbine is a device that converts the kinetic energy of wind into mechanical energy and subsequently into electrical energy for power generation. It plays an important role in renewable energy system as it provides a clean and sustainable alternative to fossil fuels. The use of wind energy began thousands of years ago with sailing ships and traditional windmills. Around the 9th century, windmills were used in Persia for grinding grain and pumping water. In the late 19th century, wind technology evolved into wind turbines capable of generating electricity. After the oil crisis in the 1970s, many countries started investing in wind energy as a renewable energy source. Today, modern wind turbines play an important role in producing clean and sustainable electricity. Modern wind turbine usually consists of large rotating blades mounted on tall towers to capture stronger wind speeds at higher altitudes. The rotational motion of the blade drives a generator, often through a gearbox, to produce electricity that can be supplied to the power grid. Today, wind turbines are widely used in both onshore and offshore wind farms and are available in different designs such as horizontal axis and vertical axis turbines, depending on their applications. Overall, wind turbines are essential technologies that support the global transition towards sustainable and renewable energy sources. So, what's the significance of wind turbine? First, renewable energy source, which is wind is a natural source and will not run out, unlike fossil fuels such as oil, coal, and gas. Second, environmentally friendly, which is wind turbines produce electricity without releasing harmful gases like carbon dioxide during operation and helping reduce air pollution, contributing to a cleaner environment. Third is create job opportunity. The wind energy industry provides jobs in manufacturing, installation, maintenance, and engineering. Next is lowering operating costs. Wind turbines have relatively low operating and maintenance costs of the installation because wind is a free energy source. And lastly, helps combat climate change. Wind turbines reduce greenhouse gas emissions, which help slow down global warming and climate change.
Wind turbines operate using several important scientific principles that allow wind energy to be converted into electrical energy efficiently. The first concept is the energy conversion principle. Wind contains kinetic energy because the air particles are constantly moving. When the wind blows against the turbine blades, this kinetic energy is transferred into mechanical energy, causing the blades and rotor to spin. The rotating rotor is connected to a generator, which then converts the mechanical energy into electrical energy that can be supplied to homes and industries. A surprising fact is that a single large modern wind turbine can generate enough electricity to power thousands of homes. Some offshore wind turbines today are even taller than skyscrapers and can have blades longer than a football field. The second concept involved is aerodynamics. Wind turbine blades are specially designed similar to airplane wings. Instead of simply being pushed by the wind, the shape of the blades creates something called lift force when air flows across them. The lift force causes the blades to rotate more efficiently and allows the turbine to capture more energy from the wind. The blade design is extremely important because even small improvements in blade shape can significantly increase energy efficiency. Engineers use computer simulation and scientific testing to design blades that can perform well under different wind conditions. Therefore, efficiency control systems are very important. Wind turbines are designed to operate within an optimum wind speed range. If the wind speed is too low, very little electricity is generated. If the wind speed becomes too strong, automatic control systems and brakes will slow down or stop the turbine to prevent damage. Modern wind turbines are also equipped with sensors and computerized monitoring systems that continuously measure wind speed, blade motion, temperature, and system performance in real time. This helps ensure safe and efficient operation. Another important scientific principle is electromagnetic induction. Inside the generator, magnets rotate around copper coils. As the magnetic field moves, electric current is produced. This principle was discovered by Michael Faraday and is still widely used today in many electrical power systems. Wind turbine also involve torque and rotational motion. Torque refers to the rotational force that turns the turbine rotor. Generally, stronger wind produces greater torque and higher rotational speed. However, the turbine cannot rotate too fast because excessive speed may damage the mechanical system.
Next is anemometer. An anemometer is used to measure wind speed in a wind turbine. It helps determine whether the wind speed is suitable for operation. If the wind is too weak or too strong, the turbine can adjust or stop to ensure safe and efficient electricity generation. Next is wind vane. A wind vane measures wind direction and helps the turbine face the wind correctly. This is important because the turbine can produce more electricity when the blades are directly facing the wind, and it can improving the efficiency. Other than that is pitch control system. The pitch control system adjusts the angle of the turbine blades automatically based on the wind speed. This helps maximize energy production and protects the turbine from damage during storm. The other scientific instrument is SCADA system. The SCADA system is used to monitor and control wind turbine performance in real time. It collects important data and helps operators detect problems quickly, improving efficiency and maintenance. Next is temperature and vibration sensor. Temperature and vibration sensor monitor the condition of important components such as the generator and gearbox. They help detect overheating or unusual movement early, reducing the risk of equipment failure. Last but not least is generator and power electronics. The generator converts mechanical energy from rotating blades into electricity energy. Power electronics then regulate the electricity to ensure a stable power supply before sending it to the grid.
I will explain examples of real-life implementations. Firstly is the Hornsea wind farm. Hornsea first started operating in 2019 and consists of 174 wind turbines. It can generate 1.2 gigawatts of electricity, which is enough to supply power to more than 1 million homes. Next is the Hornsea 2, which is begin operating in 2022 with 155 larger wind turbines. It produces 1.4 gigawatts of electricity and can provide energy for around 1.4 million homes. Together, these Hornsea 1 and Hornsea 2 are among the largest offshore wind farms in the world. These wind farms use more than 900 kilometers of underwater cables to transfer electricity to the North Killingholme substation. In addition, the Hornsea projects have brought major investment to the Humber region by creating thousands of job opportunities and supporting the Britain's renewable energy industry. Most importantly, these projects help prevent millions of tons of carbon dioxide emissions every year, contributing to a cleaner and more sustainable future. In conclusion, the Hornsea offshore wind farm shows how wind turbines can provide large-scale clean energy while supporting economic growth and reducing the environmental pollution. Next is the Alta Wind Energy Center. The Alta Wind Energy Center is one of the largest onshore wind farms in the world. It generates enough electricity to supply around 450,000 homes in California. Besides producing renewable energy, the project also helps reduce air pollution by preventing more than 5 million metric tons of carbon dioxide emissions every year. In addition, the project has created thousands of jobs and contributes tax income to Kern County, supporting the local economy and community development. To further improve the system, the Bureau of Land Management approved a large battery storage system in 2024. These systems help improve electricity reliability and makes it easier to connect and distribute the power through the electrical grid. In conclusion, the Alta Wind Energy Center demonstrates how wind energy can provide clean electricity, support the economic growth, and improve the sustainability of the energy.
Now that we've looked at how modern wind turbines operate today, let's pivot to where this incredible technology is heading. As we push the boundaries of clean energy, the instruments monitoring these massive structures must evolve too. The future of wind energy is not just about building bigger blades. It's about building smarter systems that can survive harsher environments and make independent real-time decisions. The first major frontier is floating offshore wind technology. Traditional offshore turbines are fixed to the seabed, but the strongest, most consistent winds are out in the deep ocean. Operating in deep waters introduce extreme wave force and platform tilting. To handle this, future turbines are integrating advanced 6-axis inertial measurements units and fiber optic strain sensors deep within their floating hulls and mooring lines. These instruments talk directly to the turbine's internal computer, adjusting the blade pitch in milliseconds to balance the entire structure against sudden rock waves, preventing catastrophic mechanical stress. The second revolutionary shift is the marriage of instrumentation with artificial intelligence and digital twins. Right now, if a gearbox sensor detects overheating, the turbine simply shuts down. But in the near future, AI algorithms will continuously analyze historical data from thousands of acoustic and thermal sensors simultaneously. This allows the system to create a digital twin, a virtual clone of the physical turbine running in the cloud. By comparing real-time instrument data against the digital twin, the system can predict a component failure months before it actually happens. This shifts us from reactive maintenance to true predictive maintenance, radically cutting operational costs and ensuring the grid never loses power unexpectedly. Ultimately, the future of wind energy relies entirely on the precision of its scientific instrumentation. By pairing tougher, more responsive sensors with artificial intelligence, we are turning unpredictable gusts of wind into a highly controlled, intelligent, and dominant source of global electricity. To summarize, we've seen that the modern wind turbine is far more than just a mechanical propeller. It is a highly sophisticated system driven entirely by scientific instrumentation. Through the laws of aerodynamics and induction, these machines turn wind into power. But it's the advanced sensor networks from anemometers calculating wind speed to piezoelectric accelerometers monitoring structural vibration that ensure this process happens safely and efficiently. Looking ahead, as the industry expands into deep-sea offshore environments, the integration of AI-driven predictive maintenance and digital twins will make wind energy more resilient and cost-effective than ever before. Ultimately, scientific instrumentation is the bridge transforming unpredictable natural force into a reliable, intelligent foundation for a green energy future.
In conclusion, wind turbines are an effective renewable energy source that can generate clean electricity, reduce the pollution, and decrease dependence on fossil fuels. Although there are challenges such as high installation costs and weather dependence, wind energy remains an important solution for a more sustainable and environmentally friendly future.
So, in conclusion, wind turbines are a crucial, highly efficient cornerstone of the renewable energy sector. They generate clean electricity with no greenhouse gas emissions or water consumption during operation, and their long-term economic viability outpaces fossil fuels. Despite challenges with wind intermittency and local environmental impacts, they remain essential for a sustainable future.
In conclusion, scientific instruments in wind turbine help monitor wind conditions, improve performance, and ensure safe electricity generation. Together, this system makes wind turbine more efficient and reliable.
From our overall research, we can see that renewable energy systems involve not only natural resources, but also important scientific concepts, instrumentation, and modern technologies working together. In the case of wind turbines, principles such as energy conversion, aerodynamics, and electromagnetic induction are applied to generate electricity efficiently. As technology continues to advance, renewable energy is expected to play an even bigger role in the future. Therefore, understanding this system is important because they represent one of the key solutions towards a cleaner, smarter, and more sustainable world.